Hello, I'm Sean Oslin. I'm a data scientist in the United States, and I will be teaching the introductory course in Tableau. I'm a self-taught in Tableau. I spent about 3 years sort of digging into it and learning how to do it through school projects, online projects, and on my own. And I hope to convey to you what I have learned, both in theory and in practical applications in terms of working with Tableau. The module mind map will include, first we'll discuss data visualization and why we do it. Second, we will talk about the hard and soft skills you need to make good data visualizations. Third, we'll talk about the basics of operating the Tableau public website. Next, we'll talk about how to import, join, and manipulate data in Tableau. After that, we'll work on creating common graphs in Tableau. So just what is data visualization? Well, first, it's an interdisciplinary field. And by that, I mean there are people from working in healthcare, people working in the sciences, people working in public policy, who all are creating visualizations, and they're also helping push the field forward by creating innovative new designs and learning new techniques. So there's really not a field in the world nowadays that doesn't use visualization in some way. It just communicates better than just simply talking to people or presenting them with numbers. Data visualization also is, by its very name, presents data in a graphic format. Now that doesn't mean everything has to be a graph. You can also use tables too. As a matter of fact, there's often, I have found in my experience that employers want to have both the graph that shows things as well as the data table so they can look at the data as well. Another key point about data visualization is that it's taking complex data and trying to create it, recreate it in a format to adjust, to transform it in such a way that we can actually generate information from it, and from the information we can create actionable tasks that we can do that will either move our business forward or address a problem or something else. And last but not least, data visualization is about storytelling. We have all this data up here, and then we need to put it together with other data, and then we need to say, this is what it's telling us. This is what we want to communicate. This is what the actions we need to take. So it's not enough to just create pictures with the data. We need to actually make it actionable. We need to be able to say, we've come from here, we're going here, and that's really the meat of data visualization. It's about what is the story we're trying to tell? What are the actions we are trying to take? So what is good data visualization? There's a lot of bad data visualization out there, and I'll actually show you some examples of that. But the key point of data visualization, good data visualization, is it meets the needs of your audience. And I'm going to say this over and over as we go through the course. It's like you really need to understand who your audience is and what they're looking for. So you really should ask for feedback during the development process. The last thing you want to do is spend months working on a data visualization, and then you get and roll it out and people say that's not what we were looking for. The best thing to do is to talk to them, talk to the people in charge as much as you can, if you can get access to them, as you go. And so you're actually meeting their needs. Another thing is it's not about you, it's about your audience. So don't be too clever. Don't go off and create some nifty new graph that looks really cool, but is not that easy to read. Just make sure that your audience really can understand it quickly, because they're not spending as much time with the data as you are. They need to really understand what it is that you're trying to communicate to them. Again, it's about storytelling. Good data visualization will also communicate with a minimum amount of complexity. Now you're already taking all this raw data, massive amounts of raw data, and you need to condense it down. but you need to make sure that you're condensing it down far enough that people can then make some understanding of it. But you can't make it too small either. You can't aggregate the data until it says nothing. So it's kind of a balance. And if you're not, if you don't understand your subject, you're not a subject matter expert, you're going to need to work with people who do understand the data as you go. In my experience, I have worked on several projects where honestly, I did not understand what it was that I was working on. I was not a subject matter expert in the area, and I had to continually ask for help from people saying, is this meeting your needs? Are you getting what you want? I don't understand what this means. Is this right? Do I need to join this variable with this variable? It's like, so I was like, all right, is this too much detail or is it not enough detail? And you just have to work with people because they often don't even know what it is that they want. So you have to kind of lead them through the process. Also keep in mind that if you're presenting a graphic at a meeting, that your audience is going to need to learn how to read it. There's going to be a learning curve involved for them. So again, you need to make it as simple as possible for them to comprehend the data rapidly. And if you need to have more complex backup material or things where you're drilled down into the data, you can have that as supplemental material. But again, you need to think of it, if it's being presented at a meeting for the first time, think of it like as a summary. Another thing that good data visualization does is it helps you explain concepts that are too complicated to show in words. Maybe you can actually demonstrate them through a graph, and the audience will comprehend it many times as quickly as they would if you were to just speak to them or to put it down on the printed page as text. Finally, good data visualization is ethical. You are telling the truth. And it's very, very important that you keep it in mind when you are building a data visualization. Is like, is this an actual representation of the truth? Am I skewing the data to make it look like it's something that it's not? It's like, and honestly, that's very easy to do, and it does happen, and I'll give you some examples of this, but you need to think about your personal integrity when you're building something to make sure that what you're showing is sort of a representation of the truth. Also, with regards to good data visualization, keep this in mind. We have an expression in the United States, it's called kiss, like you would kiss, your spouse. It just stands for keep it simple, stupid, or silly, or whatever. Anyway, I don't want to insult anyone, but just keep that in mind. The KISS principle, you'll hear that in meetings in the United States. So just say, keep it simple. Okay, so we've talked about good data visualization. Let's talk about some bad data visualization. This graph is what I would call, generously, to be generous about it, misleading, if not outright lying. In particular, what you should look at is the y-axis and look at how the intervals change between them. You go from 1 to 30 and then things start jumping, but to different extents, like up to 50, I believe. But the lines are all staying equidistant, the horizontal lines. So I'm not quite certain what they're trying to get across here, but this is just wrong. And I really just want to let you know that you should be real critical consumers of data visualization. And as you get better at it, you'll just start seeing everybody's mistakes. Okay, here is another example of a misleading graph. The one, to start out with, the one on the left, if you look at it, the scale doesn't start at 0. It starts at 30. So what that does is it completely exaggerates the difference between the two. When you look at the corrected graph on the right, you can see that the differences are not so extreme. And this comes back to the fact that people they look at the visualization aspect of it more than they look at the numbers. So it looks, in the one chart on the left, it looks like the differences are extreme. But once you start, once you correct it, and people won't even notice, they won't even look at the scale. But once you correct it, you suddenly get a better sense of what the truth is. Just keep in mind that Keep in mind that your audience is not necessarily data literate. They don't necessarily know how to read charts and graphs, so it's your duty to make sure that they are able to do it without being misled. How are data visualizations used? There are four main ways. First, descriptive analytics. This tells us what happened. We can look at our past financial year to see, oh, well, we made a profit or we made a loss. So it's just very, very simple. It's the most common way to use data visualization. Second is diagnostic analytics. This helps us explain why something happened. If we missed our target for something, we can go back and look to see what fed into that. What was the sort of the key elements that caused something to happen? So we can go in and just find out what the issues are. Third is predictive analytics. So what we want to do now is look into the future. We'll say, okay, we did well this year. This is what we expect to happen with the stock market. This is what we expect to happen with adding new customers, expanding our base of operations. And this is where we think we're going to be 6 months, 12 months, 24 months into the future. Well, of course, the further into the future you predict, the more problems you have with your prediction, the more noise ends up in there, and the less precise your prediction is. But at least you're trying to see where you're going to go, or even do some sort of analysis where we could look under these conditions, this is where we think we'll be, but if this happens, then this is where we think we'll be. Finally, we'll talk about prescriptive analytics. This is sort of say you are running a machine and you have certain thresholds for the operation, which defines what is normal. But when the machine suddenly goes outside the normal range, say you're getting more chaff from something that you're milling, maybe it's time for preventive maintenance. So prescriptive analytics can really come in and say, hey, look, things are not normal anymore. We need to do something about it, like get our machine serviced.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by upGrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
Tableau. First and foremost, Tableau is a database. It operates under its own proprietary version of SQL. So just keep that in mind, that is a relational database. It works with columnar data, just like any other database that you might work with. Second, Tableau is a business intelligence tool. So Tableau is also graphical presentation software. So its sole purpose is really to take data, raw data, aggregate it, and then present it in a way that is understandable to your audience, a way that you can tell stories to your audience. So Tableau is also a way to monitor existing operations. So dashboards have become very popular nowadays to be able to manage your inventory or monitor your inventory, monitor your financials, your HR, your hiring, your payroll, all those things. So are tied in with business intelligence tools like Tableau. Tableau can also help you discover new business opportunities. Through going through and analyzing the data, you're often able to say, hey, here is a market niche we have not looked at. We think there may be some real growth opportunity here, and maybe we should go in and try to exploit that. And Tableau is a relatively non-technical way of doing business intelligence. You don't need to learn Python to use Tableau, but honestly, it really helps to have some SQL skill and to have some other sort of basic computer programming skills to do stuff on the back end. The more you know about programming, the cooler you can make things in Tableau, or the more complex the business questions you can answer in Tableau. So there are many different versions of Tableau, and the one we're going to work with is Tableau Public. So what is Tableau Public? First of all, and most importantly, it's free, which is very handy because the Tableau Corporate is a very expensive proposition, and you often have to convince your employers that you need it in order to buy it. Tableau Public contains most of the capabilities that the Tableau Corporate Edition contains. There are some limitations, but particularly for people who are new to Tableau, it has everything you need to go in and learn how to make things, to make visualizations. Sometimes we hear people talk about Tableau Public. We're trying to figure out, is it software or is it a website? And the answer is it's both. Tableau Public is the free version of Tableau that you use when you're a student. And Tableau Public is actually where you store all of your visualizations. Tableau Public is, as we said, is a place you store your visualizations. Tableau Public is only semi-private. You can go in, and the default when you store things at Tableau Public is that it's going to be public, literally public. That means anybody can go in and see what you're working on. You actually have to go in and change the settings to either have your default that it's not going to be public, or you can manually hide visualizations that you're working on. I do that frequently when I'm working on drafts of things. So since it's public or semi-public or only semi-private, you might think, wow, is this a good place if I'm working on a budget for my company? Is this a good place to store the budget? And you're like, the answer is absolutely not. Do not put any proprietary material, anything that's private. So no financial, no HR, no business intelligence information at Tableau Public, because people can go in and find it. They can Google you, and they can Google your visualizations, and they can go in and see it. Even if you are going in and hiding your visualization, making it non-public, I still would not recommend you ever store anything related to your business at Tableau Public. You need to get the Tableau Corporate Edition and be able to store it either on your local computer or on a server. Finally, and this is probably one of the best ways to understand Tableau Public. Tableau Public is sort of like GitHub for your code. You can't store visualizations at GitHub, at least if you're using Tableau Public, but you can store them at your Tableau Public account. So if your boss comes in and says, why do we need Tableau? He goes, isn't it just like Excel? And your answer is no, it is not just like Excel. The slide will actually show some of the big differences between it, but let me talk about a few of those. First of all, Excel is a spreadsheet. The focus is on the cell level. The data can readily be changed, and a lot of companies consider that to be a security issue. I mean, if you can go in and monkey with the budget, then that's a very serious issue. Tableau, on the other hand, is a database. And with databases, there are specific ways you have to go in and change things. And as with Tableau, usually the data has to be changed on the feed coming into Tableau. So there's a lot more control over it. There's a lot more data integrity with Tableau. Also, with Excel, you can have multiple data types in the same column. You can also have, so you can have like texts, and you can have numbers, all those things in the same column. You can have formatting. You can have all sorts of things to make things look pretty for your end user. Well, with Tableau, it's the other way around. The data has to come in raw, and then you can go in and create all sorts of amazing sort of graphics based on the data, far more than you can do with Excel. So Excel is really an exceptional way to take the raw data and readily make it into a limited number of different tables or graphs while manipulating the raw data. In Tableau, it's the other way around. The raw data stays put. You don't touch the raw data. But when the data is brought in, then you can manipulate it. So the data is preserved, and then you can do all sorts of manipulations, pivoting the data, creating new variables, all sorts of things you can do, which you can do to a certain extent in Excel, but you have just much, much greater capability in Tableau. So there's also a big issue with size. Tableau has basically unlimited capabilities. Since it works with tables, you can have 50 different tables that are all linked together and feeding into your visualization. With Excel, you're really kind of more or less limited to one spreadsheet. You can link to others as well, but it's not as easy to do. And you have an absolute row limit of a little over 1 million rows right now. There may be more in the future. But I'll say, when you get that much data in Excel, the performance plummets. You really cannot operate Excel with that much data in it, especially if you start putting pivot tables in there, or you start doing other sorts of really complex calculations. What takes seconds to do in Tableau can take minutes to do in Excel. Now let's talk a little bit about machine readable and human readable data. Now, the example on the left is really of a budget. And this is how you would expect to read a budget. And it's got formatting in it. It's got totals, even subtotals. It has maybe some calculated numbers. And it's laid out where it's 1 month after another going to the right. Now, that's perfectly great. That's a perfect thing for Excel to do. But you can't take the data in this format and turn it into and upload it into Tableau. This is, as I said, human readable data. What you need is machine readable data, which is the same sort of format you would use for SQL or for any other database. So sometimes it's called, human readable is called wide data, and machine readable is considered long data. Now, I think really the big difference is that with machine readable data is you only have one data type per column. You only have the column has a name, and everything in that column is related to whatever that column name is. So if it's product name, everything in that column is going to be a product name. If it's going to be sales date, every date is going to have its own line. Every product purchase on those dates is going to have its own line. So instead of having data that's could be like really, really wide, showing all of these things that are going on, again, it's going to be generally the data will be narrower and much longer to account for the way that you need to upload the data into Tableau to make it readable. Now, I've often been asked to replicate data, like I want you to create this spreadsheet, but I want you to do it in Tableau. And I said, okay. And they were like, I said, what's the data? They said, well, just take the budget and do it that way. And I was like, great. So then you have to go through and reformat all of the data to get it into a long format. So I always try to say, can I work with the raw data? Because any sort of data coming out of any sort of financial database is going to be in a long format. It's going to be machine readable. And from that, I can upload into Tableau and I can create visualizations. But to take somebody's Excel spreadsheet and then create something just like it from that data in Tableau is going to require a tremendous amount of data reformatting in Excel before you can bring it into Tableau. So let's talk about some of the common chart types. First of all, we'll lead off with something that's really not a chart or a graph. It's a data table. Very common, and data tables require at least one discrete and one continuous variable. It's just a way to take all that raw data that's out there and condense it into rows and columns to make it somewhat presentable and readable, like a budget. Audiences often can quickly scan through the document to see what they're looking for, but only if they really understand the data. Newcomers to this data, they get lost in trying to work with data tables. That's why we do charts and graphs, to help particularly the new people understand what's in the data. And I will say that while I've tried to retire charts and data tables, from visualizations with more experienced people that really understand the data, they always want them back in. They love having charts and graphs, but they still want the data tables. They still want to be able to look through it. They particularly like having them to be interactive with each other, so they can click on something in the table and it will light up in the chart. One of the really nice things about Tableau, though, is it has the data tables have a drill down feature. It's a hierarchy feature. So if you want to take with data and you look at the year level and you say, hey, I want to then now drill down to the quarter level, you could just click on a button and it'll take you down. It'll expand the data so you can see the data at the quarter level. You can go down to the month level and even the day level. That's not the only type of hierarchies. You can create custom hierarchies as well to look at other things. Like say you have want to look at global sales, and then you want to look at regional sales underneath that, and then you want to look at countries under the regions. You can create a custom hierarchy that will then show up in a data table. One of the really nice things about data tables is that you can add conditional formatting to it. So say you want to highlight where you're making the most money or where you're losing the most money, where there's been the most amount of change. You can create a table and you can go in and color it using some functionality within Tableau. So you can help highlight. So you can, this is for people maybe that aren't as familiar with the figures. They can immediately see where there have been the biggest increase or their biggest decrease. Now we'll talk about our first real chart, a bar chart. Most basic of all charts. Bar charts have to have at least one discrete variable and one continuous variable. Bar charts show the relationships between a group and a subgroup, or between subgroups. So you can compare total sales in one group versus all the others, or you can compare the percent sales for like a region against just the sales for the entire company. So you can see what proportion of the sales for region X are going in towards the entire company. Now in the slide here, the graph is bar charts horizontal, and you can certainly make it vertical as well. It just kind of depends on what your needs are. It's very easy. There's a simple button in Tableau. You can switch to toggle between which way you want to have your axes. Next, we'll talk about a line chart. Now, a line chart most commonly will have two measures, two continuous variables. That's not always the case. You can always have one that's continuous, one that's discrete. However, with line charts, usually one of the variables is always going to be time-based. So you end up with, you're looking at starting on January 1st and going through to December 31st. That's very common for line charts. You could do that with bar charts too, but they look a lot better with line charts. In Tableau, you can change the interval though. If you want to look at it on an annual basis, it'll look one way. If you want to look at a quarter, month, or day, it'll just provide progressively more granularity when you're looking at the data.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by upGrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
Next, we'll talk about tree maps. Tree maps require one discrete and one continuous variable. Tree maps are really good for showing the part-to-whole relationship. So if you have 4 regions and you want to look at how each of them fit in relative to the whole and how they fit relative to each other, a tree map is really a good option. Now, tree maps have a few features to them that really help you read them. First of all, the upper left-hand corner is always going to be the largest share of the total. It's going to be the largest size, and it's also the highest. Also, it will have the largest area of any of the subgroups, and finally, it will have the darkest color. So that really is a great indicator for how to read the tree map. Audiences can learn to read tree maps very rapidly. The drawback of a tree map is you can't really see the absolute differences between size. You can see the relative difference. You know that the upper left is larger than the lower left, but unless you put in a tooltip in Tableau like I did in this example, you can't really gather what the absolute size difference is between them. One of the problems with tree maps is they can get too complicated. They're still easier to read than trying to read a pie chart. They're still easier to read than pie charts, but they can get very complicated. The example that's in this slide is it's a fairly complicated one. I've seen far more complicated ones, but you can kind of get a sense that you can get a little overwhelmed with all the different squares in there, and so you just have to kind of keep in mind that are you communicating to your audience? Does your audience understand it? Will they understand it readily? So again, it's always trying to keep your audience in mind. If you got people that are really in the know, who really understand your data, maybe this will be okay. Maybe not. So you just kind of you learn from experience and certainly ask for feedback about this. Next, we'll talk about scatter plots. Scatter plots require 2 continuous variables. One variable is going to get plotted against the other. So a good example of that is profit and sales. So if you want to see how profitable an individual sale was, you can plot them with each other. The graph itself, the dots on the graph, will actually show how the performance of one individual component is, one individual pairing, like a sale and the profit from that sale. But taken together, they show patterns in the data. They can show if there's clusters. They can show if it's a positive relationship. So the higher the price, the more the profit. Or they can, there's just many other things that can show up in there. They can see whether there's a linear relationship between 2 variables or something else. So they're very valuable in that way in terms of, but they're very valuable. But they do take a little bit of training for your audience to understand. They might not all get it right away, and they might get overwhelmed with all the dots. So just keep that in mind. Okay, next we'll talk about maps. Now, I will tell you that Tableau is not map specialty software. It's not mapping specialty software. It has some map capability, and what you can do with it is really powerful. But if you're really looking at digging in and using maps, might want to consider something like ArcGIS, which is immensely complicated to learn. People get advanced degrees and just learning how to work with maps. So, but anyway, what you can do in Tableau is still very powerful. So the default map in Tableau is called a choropleth map, which is a term I had never heard before I started working with Tableau. And it requires one continuous and one geographic variable. You can also include discrete variables as well, like a region or something like that. But it does require one continuous and one geographic variable. Now, the map actually shows the relationship, between whatever variable we want to look at, say sales, against the subregions or the geographic divisions that are within the data. In this case, we're looking at sales within one region of the United States by state. And you can see that the southern state, which is the darkest, that's Texas. That's where the highest number of sales are. Okay, now we're going to have to go back a little bit into theory to really help clarify some of the most confusing concepts in Tableau. First, we're going to talk about the concept of dimensions versus measures. Now, dimensions are qualitative variables. That's the most important thing to keep in mind, qualitative variables. They are names of products, names of clients. It could be an ID number for a product if it mixes both letters and numbers. It can be geographic data, and it can be date data. We use the dimensions in Tableau to sort of to segregate the data. So we want to look at these particular dates. We want to look at this particular geographic region. We want to look at these categories of products within the company. So your dimension is always going to affect something we call the level of detail in Tableau. The more dimensions you have, or the bigger that the actual dimension is, the more details you're going to be drilling into. So you need to kind of find that balance about showing, providing information for your audience without completely overwhelming them with all of the data. So this slide actually shows an example of just looking at the raw data for sales with no dimensions in it. So you're just looking at the data. So you can see, okay, this is what the total sales are. But that's not really all that helpful when we want to actually see, well, how do each of the regions do? So we add the region dimension to it, and suddenly it divides up the data, and we're able to see, oh, this region performed better than this region. Next, we're going to talk about measures. Measures are numbers. They can be counted, they can be subtracted, they can be multiplied. You can apply percentages. You can create special calculations with them. You can multiply them together, more than one measure. Anyway, they're all of the numeric, the purely numeric elements that you have in your data tables that you're pulling into Tableau. There's lots of things you can do with them once the data's in there. When you work with dimensions, the dimensions help segregate the data. So you, instead of looking at just all the total sales, you're looking at the sales by region. And that's really important to keep in mind, is that there's Tableau's default is just going to give you the raw number. And then with the dimensions, you start dividing it up into something more meaningful. And the other thing that's very important to keep in mind is that the default for Tableau, when you pull data in, is it's going to sum the data. And it'll give you a pill like it's in the slide there, with it says that it has the variable name and then it has sum in front of it. So you can change those. They don't all have to be sum. You can change it, and I frequently have in projects that I have worked on. So now we're going to talk about pills in Tableau. You're going to see blue pills and green pills in Tableau, and you're going to wonder, wait, what is it? What's the difference? Well, the important thing to keep in mind is the blue pill. While most blue pills come from the dimensions section of Tableau, a blue pill is not necessarily a dimension. A blue pill represents discrete data. as opposed to continuous data. So discrete data like names, keep that in mind. So you can actually have dimensions that are actually green in color. That means you have dimensions that are continuous. That often happens with dates. But keep in mind that the blue pill, it represents discrete data, not a dimension. Also, the green pill represents continuous data, not a measure. Concepts are very important because this is often an interview question. Please explain the difference between a green pill and a blue pill. And often people get it wrong. So just remember, blue is for discrete and green is for continuous. Now the chart on the left uses a date as a discrete variable, and you can see how the data is broken up into discontinuous lines based, in this example, based on quarters. And then on the one on the right, the data is continuous, so it's one continuous line with no breaks in it. And you may say, well, why would anyone want to use the one on the left? But honestly, it does come up. Sometimes people want to see the data presented in different ways, but you do have the option of right mouse clicking on a continuous variable and turning it into a discrete one, and you can also do it the other way around. So some of you may decide that you want to specialize in data visualization as part of your data science career. It can be a lot of fun to do that, and there's certainly plenty of jobs out there for people who are interested in this level of specialization. So the question is, like, how do you actually get yourself hired? Well, like with artists or with other sort of professions, you have to have a portfolio to work with, and something that you can show potential employers how you've done your work, what you've learned, what you're capable of. So the best way to do that is to actually go in and then just do all sorts of visualizations. So you can go and look at YouTube videos. There's all kinds of how-to videos. How do you build a Sankey chart? And you can go in and you can just find it and like, wow, that looks really cool. And usually they have the data there. You could download it and you can create visualizations, learn how to create new visualizations from a 10-15 minute video on YouTube. And then you save it to Tableau Public. And when you've cleaned it all up, make it look professional, it's like, wow, okay, then you got something you can add to your portfolio. That is your portfolio. Tableau Public is your portfolio. You can also do the same thing with your class projects here. They will all be part of your portfolio. And you could do classes from Udemy or other online schools. I have a tremendous number of visualizations which I've done in online classes, and I've taken a lot of them. So I would just make sure though, when you may just do it very rapidly in one of these classes or one of these videos, clean it up. Make it look professional. Do all the sort of best practice things that we'll talk about to these things, and you put it up there, and that is your representation of your portfolio for Tableau. So another way you can build your portfolio is by doing personal projects. The one listed here is a COVID-19 project that I was working on my own while I was job hunting a while back at the beginning of the epidemic. So I was getting the data daily, and then I was updating it every day with the new data. I would just go in and connect to the new data set, and it would update it daily. And this was on in my Tableau Public portfolio. It's something that employers could see, and it helped me when I was looking for a job. Probably because I had so many of them. I had like 50 visualizations in there that I had built up in my portfolio. And that was just a big selling point when I was talking to employers. Finally, in terms of building your portfolio, you can do some of these really fun things like Makeover Monday, and which is it's a website and it's a book and it's a I don't know if you really would call it a competition. Maybe it is, but they take a data set every week and then they go and redo it to make it, take somebody's visualization, then redo somebody's visualization, or they just work with raw data and then they just create new visualizations based on it. And people can post what they've done and people can vote on them or comment on them. And it's a great way to learn. It's a great way to improve your skills. One company I worked for, they did a makeover Monday once a month, and so everyone got the data, and then they had a week where they could work with the data, and then they came back and everyone presented what they had done in a big meeting. People who wanted to show off theirs, so they could say, "Oh, this is how I did, this worked with this data set and what I came up with." So it's a great way to just to learn new skills and to actually make some connections within the Tableau community. If you're really interested in data visualization as a career, I really would encourage you to look at Tableau's certifications, and these are really helpful in terms of showing to employers that you have the job skills to meet either sort of beginning to intermediate to all the way up through advanced or very advanced Tableau skills that you can that they can use in their workplace. So I have the specialist certification, which is the first one on the list, and that's really helpful. I have that on my resume. I have it in my signature line of my email, along with the link to my Tableau public account and also my GitHub account. So I really would recommend that you look at it. They often will have a sale on it because it still costs like minimum of $100, but it is really a great thing to show that you've actually had some of the skills involved. And there's quite a few trainings involved with it, or you can do through Tableau. You might be able to find them less expensive through Udemy or something like that, but you can take a look. But there are actually specific courses out there designed to help you pass the certification. I would start out with the specialist and then work up from there. I don't know much about the data analyst one. That's brand new, and I haven't had a chance to explore that one yet.